Hello guys, now moving ahead for the gaseous state, now we are going to discuss a very important concept that is called the kinetic theory of gases. Various scientists like Maxwell, Bernoulli, Boltzmann involved in the development of this theory. Whether Maxwell and Boltzmann are very important scientists. They have actually shaped this kinetic theory of gases. They have given some assumptions, and depending upon those assumptions, they try to explain some of the properties. They derive an equation also, and that equation gives a relation between pressure and volume, and from that relation they deduce all those gases which we have discussed already. So Boyle's law, Charles' law, pressure, temperature, all those gases can be deduced from this kinetic gas equation. But what are those postulates? What are those assumptions? And those assumptions at that time were valid because they consider such kind of gases are ideal gases. Okay. So what are those postulates? First postulate is all gases consist of tiny particles, and those tiny particles are called as molecules. Okay, molecules. So that is the first point. All these molecules are in a state of rapid random motion. That means the molecules are not fixed at a position, at a particular position. They are always moving randomly. Okay, so rapid random motion. Of the molecules, and since they are rapid random motion, they collide with each other and with the walls of the container. Okay, and that collision is elastic in nature. So what do you mean by elastic nature? Before the energy involved before collision and after collision remains same. So there is no loss of energy after collision of molecules. Hence that collision is called as elastic nature, elastic collision. Okay. Then because of this collision or because of this rapid random motion, molecules collide with the walls of the container. At the same time they collide with each other also. Now the collision with the walls of the container actually exert a pressure. So pressure exerted by the gas molecule is because of collision with the walls of the container. Okay. So pressure development. Pressure of a gas is due to collision of molecules with the walls of the container. Okay. And that pressure, high or low, depends upon the frequency of collision. So the magnitude of the pressure depends upon the frequency of collision. Then volume of a gas molecule is almost negligible as compared to the total volume of the container. So negligible volume of a gas molecule. Now that is in comparison with the total volume of the gas, total volume of the gas container. Okay. Then since the molecules are in a rapid random motion, they have a particular kinetic energy. The average kinetic energy of the molecule average kinetic energy of the molecule is directly proportional to absolute temperature. So, as you increase temperature, kinetic energy will increase, or if the kinetic energy will increase, temperature of the system also increases. Okay. So, these are some important assumptions for the kinetic theory of gases. One more important assumption, and that assumption is there are no interacting forces between the molecules, means there is neither attraction nor repulsion amongst the molecules. So, I can say no interacting forces between the molecules, which means these gas molecules are actually isolated particles and they are moving with their particular velocity, with their particular kinetic energy. As soon as they are in front of the ball, they collide, hit back and start. There is no loss of energy at all because that collision is elastic collision. So, the energy of that system is always conserved. Okay. So, this is all about the kinetic energy, kinetic theory of gases. From that, we have all using these postulates and using certain derivations, certain assumptions, there will be equation called as kinetic gas equation. So, the derivation part actually people are studying in a physics. There is a chapter kinetic theory of gases. So, here we are not going to discuss how that equation has arrived. You will be discussing that in a 12th standard. But equation is very important. Equation is PV is equal to 1 by 3 m n c bar square. So, it is not a c raised to minus 2, it is a c bar square. So, P stand for pressure of the gas, V stand for volume of the gas, this M stand for mass of one molecule, N stand for number of molecules, and C bar stand for root mean square velocity, or just we call it as a RMS velocity. RMS velocity. Okay. So, this is the equation, kinetic gas equation. Now, if we compare this equation with our ideal gas equation, what is that equation? PV is equal to nRT. So, if we compare for 1 mole, we can write this way, PV is equal to RT, right. So, equation becomes RT is equal to 1 by 3 m c bar square. So, that m becomes molar mass of 1 moles, that is molar mass of the gas. Okay. So, further we can write this as c bar square is equal to 3 RT upon m. So, c bar is equal to square root of 3 RT upon m. This is the equation for the root mean square velocity. Now, if we are talking about n number of moles, okay, for n moles, so I can divide this equation by n. So, RT by n is equal to 1 by 3 m by n c bar square. Okay. So, R by n is actually called as K, which is called the Boltzmann constant. Boltzmann's constant. Therefore, C bar is equal to, you can write 3 kT, okay, 3 kT, m by n is the mass of one molecule. So I can say C bar is equal to what? Square root of 3 kT. Root means square velocity per molecule, RMS velocity per molecule. So this will be the final relation for the root mean square velocity. Okay. Now beside root mean square velocity, is there any other kind of a velocities? Why are we considering only this RMS velocities? What about average velocities? If the velocity of the gas molecules are different, there must be average velocity. So what is the relation between RMS velocity and average velocity, or any other type of velocity is present or not? All that we have to discuss. Okay, that we'll see in the next session. So R by N is equal to K, that is equal to Boltzmann's constant. So this becomes 3 kT is equal to m by n, that is mass of one molecule. So m C bar square. Now dividing both the side by 2, so we can write 3 by 2 kT is equal to 1 by 2 m C bar square. This is nothing but kinetic energy of one molecule. So kinetic energy per molecule is equal to 3 by 2 kT. So we got a relation. That relation gives you idea about kinetic energy and temperature. So we can say that since the K is Boltzmann constant, kinetic energy is directly proportional to absolute temperature, which was assumed in kinetic theory of gases. Okay, thank you.